Okay, so one thing that comes into play when you're measuring moisture is the ideal gas law. Everybody's covered that at some point in their lives, high school chemistry, college chemistry. The ideal gas law is simply PV equals nRT. So in a given system at equilibrium, pressure times volume will equal the number of moles times the temperature times the ideal gas constant, R. Okay, so it's just simply, that is also an equation of state. It's a way of relating physical properties, in this case, pressure, volume, and temperature. Okay, so basically the graphic here shows that if you've got a cylinder in one condition, and then you plunge the plunger down within that cylinder, and you reduce the volume. So in the example, it goes from 1 liter down to 0.5 liters. What happens? Well, for one thing, the temperature will go up. So that is what the ideal gas law is used for. It's the relationship of those three parameters within a closed system. Okay. Another important law is called Dalton's law. Dalton's law is really simple. It basically says that if you have a gas mixture in a system or in a chamber, and you're able to measure the pressure that each type of molecule exerts. For example, we already talked about water vapor pressure being the pressure that just the water molecules exert. So if you had a special pressure gauge that measured that, and then you had another special pressure gauge that measured the amount of pressure nitrogen molecules exert, and another one for oxygen molecules, that's basically the makeup of air. So if you had those three special pressure gauges and you used them and then you added their readings together, that would equal the total pressure of the system. So basically Dalton's law says that the total pressure of a system is the sum of all the partial pressures being for each component within the system. So mathematically, PT equals P1 plus P2 plus P3 all the way out to the ith component, if you will, so all the way out for all the components. Okay. So there is a relationship between dew point and pressure that is very important when you measure dew point. Okay, so if you look at the example here, and you have a cylinder at 1 atmosphere, which is 14.7 psia or 760 millimeters of mercury, just depending on what units you want to use. And you measure the water vapor pressure within that cylinder. So let's just say it's air, and the air has moisture in it. And the water vapor pressure is 0.0966 millimeters of mercury. Well, number one, if you use a water vapor pressure table and you look up 0.0966 millimeters of mercury, you'll see that that's a dew point of minus 40 centigrade. Okay, so let's say you then take your plunger and you plunge it down and you raise the pressure to 2 atmospheres, which is 29.4 psia or 1520 millimeters of mercury. The question is, how does that affect the dew point? So on rough terms, does it go up? Does it go down? Does it stay the same? So if you think through what we've just talked about in terms of the ideal gas law and Dalton's law, if you increase the total pressure of the system, that means you increase all the partial pressures of the components. So if you double the pressure, that means that the pressure the nitrogen molecules exerts doubles, the pressure that the oxygen molecules exerts doubles, and the pressure the water molecules exert doubles. Okay, so what happened is by increasing the total pressure of the system, you've increased all the partial pressures, including the water vapor pressure table. So what does that tell you? We know that every dew point has its own corresponding water vapor pressure. So if you've changed the water vapor pressure, that means you've also changed the dew point. And sure enough, in this example, if you increase the pressure from 14.7 to 29.4, the dew point will go from minus 40 centigrade to minus 33.7. Okay. So the takeaway here is dew point is a function of pressure, period. Okay, so if somebody tells you they have a certain dew point, the next question you would normally ask would be, oh, what pressure is associated with that dew point? Okay, the only time you don't really care about that is if, you know, you're always operating at the same pressure and your dew point goes up or your dew point goes down, or better stated, the dew point goes drier or the dew point goes wetter. Then, you know, as long as you're at that constant pressure, then you're getting a clear view of what your moisture content is doing, getting wetter, getting dry. But if you have a change in pressure, then it is very important that is understood, because dew point is a function of pressure.